Hello, good evening, one and all. Today we are here to gather for Sidecore Hyderabad Sidecore event, wherein we have Vishal and me who are hosting this event, and we do have speaker as Sathyamoorthy, who is going to talk on about uh, integration challenges within the composable architecture. Over to you, Sathyamoorthy.
Thanks, Yamini, Vishal. All right. Hello, everyone. Thank you for being here today. It's great to see many talented individuals gathered around here. As many of you already aware, like composable solutions brings incredible opportunities to us. We are talking about building the systems which are flexible, scalable, and adaptable to change. And the potential scope and learning here is always huge and amazing. But let's be honest here. Whenever there is a topic, something came in, integrating all those different modules, whether it is part of Cycle products or outside of the external products. So the integration, I can read all your kind of like mind voices. Yes, that's where the real challenges are lies in. And that's exactly what we are going to explore it today. So let's dive into the today's topic, tackling integration challenges in composable architecture. Myself, Sathyamoorthy, working as a lead software engineer at AssureX. And you can call me Satya, by the way. Yeah. So today I'll walk through some common pitfalls, best practices, common practices which has been experimented and kind of like tried it out with lean approaches and some real world examples. I hope at end of this session, you will have the insights to unlock the power of modular solutions. Once again, thank you for being here and let's get started. So before we dive into the today's topic, I want to share a quote that perfectly captures the spirit through this journey. Think about the challenges which we had come across so far in our path. Each one is an opportunity for learning and growth. So, in this moment, I would like to thank my mentors, colleagues, and of course, community friends who all played a key role in guiding me through this journey. So, as usual, I would like to give you a brief outline what I'm going to cover today's session. We will be discussing and we will be brainstorming about composable architecture. So, I'm not going to take much time on that part because most of us already come across that area. Common integration challenges, especially transitioning from monolith to composable solutions, and some of the best practices which I have learned and kind of like witnessed from my team as well as we tried, and case studies, and key takeaways, and brainstorm sessions. I'm particularly excited about the last section, which I would like to name it as a curiosity corners, because I believe in crowdsourcing, where I can get to know some new concepts, new ideas from you, all of you guys as well. So let's start. The picture displayed here, it is not something new and much familiar to most of us. In fact, I'm very sure we have all encountered at least one of these products during our journey. While this picture may look sleek and appealing at first glance, what truly matters is what's happening behind the scenes. Integration is the unsung hero as always, and it's the backbone which makes the system robust, resilient, and fault tolerant. Without seamless integration, even the most polished system can also collapse under the pressure, which you have seen in the past. So, but I'm not going to kind of like get into the deeper into these offerings from Sidecore, at least not now. Instead, let's flip this picture to see like what really powers behind the scene of this one. So if you see here on the left hand side, I've just listed out the elements, and the right hand side characteristics which would define, okay, it's a composable architecture kind of. So let's start from the characteristics because in the upcoming slides I'm going to talk about elements. From the characteristics perspective, if it is a composable architecture, whether it is kind of like a nth component or kind of like n plus one component. So the ultimate goal of that all the systems integration to be kind of like one common goal, that is user-centric design. And at its core, like composable architecture is built on the principle of modularity. So which is more like a kind of like a building blocks, easy to integrate and easy to kind of like a scale up as well. Interoperability, which is what truly empowers composable systems. Each module within the architecture can communicate seamlessly with others, regardless of the technology or platform it is built on. Scalability. It is one of the biggest advantages of a composable system. You don't need to kind of like, we don't have to overhaul the entire system to meet the growing demands on specific areas or specific components. So this targeted scaling keeps costs down and enhances the system performance as the business grows. So the resilience, because of each module is decoupled, the failure of the one doesn't bring down the entire system. The system is designed to handle the failures gracefully, which is allowing it to continue while the affected components isolated, also it's fixed. In other words, the system stays up and running even during an outage, ensuring high availability and minimizing the downtimes. So these are all the characteristics which would define, okay, it's a kind of like composable architecture. Now we're going to look into the elements. The composable components, I'm kind of like naming it as business function parts. So the main idea is simple here. The larger systems are broken down into smaller parts, and each individual part is having their own responsibility. They can be combined or rearranged as needed. This gives us the flexibility. So we can kind of like choose what we want, and we can build and adjust the systems quickly without starting from the scratch. The main intention here is like a cloud first and go with the kind of like a SaaS. Now let's go over some key characteristics of this composable components. Modular units. So these are all the building blocks of our system. Each one has a specific purpose, which must be defined. Also, it should be kind of like one single product should be having kind of like a definition of done so that it can be easily testable as well. So the next is like a component is an autonomous, which meant it can operate on its own. It doesn't rely on other parts other than the input and output policies which has been defined and responsibility assigned to its components. Compatibility also kind of like important, that depends on kind of like what it's responsible for. And it must be API driven because component has to talk each other. So API is a medium. API ensures the data services flow easily between the parts. This keeps the entire system interconnected. Finally, outcome focused. As I mentioned earlier, so each composable component should be defined with the kind of like a proper DoD and responsible, what it is, I mean, what its scope and what it is responsible. So these are the key characteristics that define. Sorry,
Sorry.
someone wanted
Go
to.
ahead, Satya. Go ahead, Satya.
Yeah. Thank you. So these are the characteristics that define the composable components. Now let's move into the kind of like a next element. So this is kind of like inevitable. We would have seen microservices and micro front-end services. Let's explore like microservices. So these are all kind of like a specialized teams in an organization, and each one has unique expertise to take care of individual modules. So this separation enhances the efficiency as well as adaptability of the systems. Micro front-ends. This also kind of like a microservices built on this same idea, but they break the user interfaces into smaller, independent pieces. Each micro frontend can be developed, deployed, and maintained separately. Let's take an example. In an e-commerce solution, we may have a kind of like a listing page, product details page, and checkout process. So the different teams can choose their technologies. For example, like a product display, they can use React, and a cart, they can use Angular. So it is something kind of like we can uh, coordinate and we can orchestrate this entire solutions flow in this way. In summary, the synergy between kind of like microservices and micro frontends. It is kind of like architecture enabling the agility, responsiveness, and innovation in a fast-changing digital world, which we are experiencing it now. Let's go to the next slide. Service mesh. So Like we were in the era from kind of like service oriented architectures into digitally composable experience solutions now, but just with the microservices, which is not kind of like sufficient to handle and define the characteristics whatever we had seen in the composable components. That's why we had gone with kind of like a service mesh. So which is it is a kind of like a layer which just manages the communication between microservices in a large distributed applications. In the main role of this one, like the network-based communications, ensuring it is kind of like a security, reliable. Also, like it is taking care of observability between the service-to-service interactions. It has two components: data plane and the control plane. So data plane is responsible for managing the traffic between the services, whereas control plane provides a configuration and policy management for the data plane. So here, the main purpose of using service mesh like traffic management. So routing and load balancing between services can be handled within this service mesh. Security, same. Resilient is a kind of like a main purpose. So we can configure like circuit breaking and service failovers. And the main kind of like a reason to go with service mesh when we especially handling the large and complex microservices architectures, this service mesh is kind of like important. But when we go with the kind of like a smaller small scale system, just kind of like a serverless functions, like that time we don't want this kind of like service mesh stuff, because the moment when we keep adding them, it's going to create the complexities more. Anyway, we'll be discussing this part in the upcoming slides. All right, so now we are pitched in into the kind of like a area which we wanted to discuss about it today, complex composable playgrounds. Usually these are all the areas, uh, especially in the first four, it is kind of like a common. And the last second point, which I wanted to kind of like discuss it with my own experience. The first one, authentication and access governance. Let's get into that one. When we have a kind of like a large scale system, authentication is kind of like always challenging. The composable architecture becoming the trending standard in application development nowadays. By deconstructing the systems into independent interchangeable services, we are going to unlock flexibility, scalability, and accelerated development cycles. So we are, I believe, like most of us had watched Spider-Man movie, and as Peter's uncle Ben wisely stated, great power comes with greater responsibility. This modularity provides numerous benefits, but it also brings increased responsibilities to address the challenges, especially regarding the identity management in a distributed environment. As we have multiple services interacting through the public endpoints, securing authentication and authorization becomes a complex task. The stateless nature of microservices also makes an additional kind of like complexity. So this is especially challenging when the customer can only interact with the system through the user interface. Let's explore some of the key complexities involved, or we can effectively address them in the upcoming slides. So here we can take a kind of like a workflow, the access governance, like if you are using kind of like OpenID or kind of like a social media, like through three-legged authentication kind of stuff. So this is kind of like essential. When the user logs into the website, the request first, when they use an URL first, it goes to front end. And front end, it would check the kind of like cookies or kind of like a cached data, whether the user has any context in the browser. If it doesn't have any authorization context, it will redirect the user back to the kind of like a challenge page. So once the challenge is kind of like a done, that information will be flown back to backend for front end system, which will be kind of like configured as a redirect URL in the kind of like authentication, I mean, OpenID system. So once the challenge is succeeded, then that information will be writing an authorization context back to the front end system. And microservice, every request tied up with the front end to back end, it will be having the cookie information of authorization context. By using that context, microservices will get to know the user identity through this one. So this way we can make sure authentication and access governance is achieved. I'll go to the next slide. Data synchronization and consistency. First, I'll bring the point like why data synchronization is necessary. I believe like centralized data is kind of like quite benefitful, but in our composable architecture, not only in composable architecture, any of our solution, we usually having kind of like a benchmark. So we don't want any API calls or any page request shouldn't go more than 3 or 4 seconds of the duration. But when we have a kind of like centralized data in a common place, we have kind of like system distributed across multiple components and microservices. Just think about the kind of like a response duration on the specific request. So it is kind of like tough. So that's why we wanted to kind of like keep the data scattered across as a fragmented pieces. Our first challenge, like as I said, it's a fragmented data sources. So the solution, what we can do, we can go with the kind of like a Azure data lake formation, which would allow us to kind of like merge the sales data. This is a typical e-commerce solution. I'm just taking an example. And the customer information, we can use kind of like we can use them to store it in the Azure data lake formation, and we can use the system to kind of like collate them and merge them as the real-time insights. Next one, real-time data updates, which is kind of like essential, especially in the e-commerce systems. So we can opt for event-driven systems like kind of like a data streaming system, something like Apache Kafka, to ensure real-time transaction streaming. When the users makes any purchases, the transaction is immediately reflected across all the systems using the kind of like subscriber options, which is available in the Kafka systems. We will be discussing that part, or like I can take you in depth into the next slides. Data governance. When the data is scattered across multiple components, it is another key challenge. Also, it is vital to maintaining the data quality. So let's take an example, like in a healthcare organization, data stewards, which can be built using Power Apps, which can oversee the records. It can kind of like scan them and it can identify any personal identify informations, or like we can have our own rules to streamline the data qualities. So the next is the kind of like a complex integration, often arising from variety of technologies being used. Especially this complexity can also slow down the processes and hinder the collaboration. An effective solution adapting an API first approach. Excuse me, let me drink some water. In summary, while ensuring the data consistency and synchronization poses significant challenges in composable architecture, we can effectively addressing them through the targeted strategies and real-world solutions. Learning from these examples will enhance our composable system and drive better outcomes. Let's move on to the next topic. So this is another one example for the kind of like event-driven architecture. Let's assume we have an front-end headless front-end solution available in the site, and we have a microservices which is like order service. Also, we have a kind of like a system. The data gets indexed in the search stacks. If you wanted to kind of like do any kind of like a purchasing, so we are always doing it through order service that will connecting to the. Let me minimize this. Yeah. So we wanted to place an order into the Dynamics 365 system through the order service. So this is kind of like a typical way, but here again we need to kind of like take the data back, and we need to kind of like update it in the next day solution, and index also to be updated with the quantities in case if the product is sold out, then remaining quantities to be updated in the search index. Once the order is placed, then order service, it is taking the responsibility kind of like update the index back in the search stacks. Instead, we can think it of an data-driven architecture. Let's say when the order is started from the user side, then we are passing it to the Apache Kafka system, and this will be fed into the kind of like producer part. And as soon as the data flows to the Apache Kafka in the producer part, it will stream the data. It will stream the data back to the Dynamic 365 system as an purchase action. Once a subscriber one is done, then next that update inventory details back to the search tag system. So this is kind of like a decoupling the process instead of directly accessing ERP systems to do any purchasing event. So next taken another one example. In our e-commerce solution, so we would have seen kind of like a multiple life cycles starting from kind of like a product tailoring activities and a cart, shopping desk, purchasing and fulfillment, and then like reviews, all of that stuff. In this overall journey, there are so many activities, so many data being involved. But what we can do it here is like we wanted to capture entire information to be traceable. We can pass, it is kind of like very high level example. We can pass this data to the Apache Kafka, and that information will be fed into the Azure data lake. The information will be kind of like processed by the Spark cluster, which will be kind of like a data processing system. It we can write our own custom rules in the system to make sure is like data gets refined in every iteration. Let's take an example. When we pass the data here, it goes to Azure data lake information. The same data again refined and passed back to Apache Kafka cluster. Again, the same data refined. Then finally, information gets stored here. And from this Azure data lake information, Azure data lake, we can get the real-time data in our Power BI dashboards. We can provide it to the business. So it is kind of like a flexible and compatible for people to understand what's happening across these life cycles. And we can consider this approach for an kind of like real-time traceability as well as observability steps as well. Go to the next slide. Change management. This is kind of like another complex area, which is something like always, I mean, it is troubling everyone in the recent days. Adopting a composable architecture poses several challenges in terms of change management. As this architecture comes with the flexibility, modularity, and sorry. So here we can see the kind of like a challenges in the change management. One is like a resistance to change, especially people were working with who were like working in the modular system. When a sudden kind of like movement, if we ask them to kind of like work on such a organized or coordinated way of change, kind of like a environment, it will be very difficult for them to coordinate with cross-functional teams and kind of like subsystems, upstream systems and downstream systems. So to overcome this kind of issues, like we can plan for a kind of like a training, and we can always ensure like coordination and communication, and kind of like it is cross-functional scrums, and we can have a kind of like common ground to have the updates. So those kind of stuff will mitigate uh, the first issue. So the governance and oversight. So this requires kind of like a dedicated change management team or like a release manager to take care of this kind of stuff. So uh, the solution, what we can do it here is like we need to kind of like define the policies and protocols and guidelines that ensures the consistency in every module during the development. And we can take kind of like rollback and recovery. Uh, when we say rollback and recovery, the every kind of like a version across the components that has to be tagged and which should be having kind of like downward compatibility, backward compatibility and other stuff. Interdependencies between the modules. As services become modular, the complexity of managing interdependencies between these modules increases a lot. Changes in one module can impact another module. This would happen anytime. Then automated deployment pipelines, CI/CD pipelines that we had seen. So here, we need to use kind of like webhooks to maintain the workflows, to make sure like one component, I mean, dependencies of one component is always tied up with another one component's input. So that we need to kind of like make sure through the pipelines. Then these are all the part kind of like we had seen, and I don't wanted to kind of like go with each one of them. Observability and traceability. So we had seen these words. Observability is nothing but kind of like uh, it is ability to monitor the each resources and utilization, and it is like a vitals. Traceability is something like the system flow and data flow, and in case of any issues or in case of any kind of like a troubleshooting, we need to kind of like use the end of the ropes, and we need to kind of like trace them down through across the services. So the main purpose of them, like it will easier the debugging experiences. Also, it will help the audit team to other with the compliances part and monitoring. Like nowadays, SRE software reliability engineering. So this is kind of like very much useful in case and in case if they kind of like go with the large scale systems. All right, I'll go with the next one. The versioning. Uh, the first point which you wanted to kind of like bring in semantic versioning. So usually when we have a kind of like large scale systems and the two multiple teams taking care of the deployments on across the kind of like a solution, so we always go with the kind of like a major minor patch. So we'll go with the kind of like this options to make sure the criticality of the deployment, and other teams will be coordinated based on this one. APIs, since all the components are interconnected through the APIs, so we need to kind of like maintain the APIs versions as well. There are multiple ways. In case if it is kind of like on the URL, the path changed, we can go with the URL versioning like V1, V2, V3 kind of. If it is a header, then we need to go with the kind of like a header specific versionings. If it is parameters or payload, then we'll go with them. But ideally, this must be kind of like a version. Then backward compatibility, which you had seen in the change management. So the new version, whenever there's a new version of the components, kind of like are going to be deployed, and we need to ensure it maintains the backward compatibility. So this allows the clients to upgrade gradually. When I say clients, like it is a cross-functional systems, so they can easily upgrade and without having any kind of like troubles. Future toggles. So this is another one, kind of like a future or like a check thing. We wanted to maintain it. Let's say component A, component B is having some dependencies with component A. Whenever there's a new releases goes on, we used to have a kind of like a future toggles. So if there are any issues or something, we can usually toggle it off so that the new feature will be toggled off. So this would allow us to kind of like ensure the resilient. Then dependency management. So we can use the tools, kind of like we can use the tools to kind of like come into the dependencies, and that can be kind of like documented. Also, like if it is especially in the front end, what we can do, like we can use a shrink wrap or pipe environments to ensure that specific version of the dependencies are used across the environments. Documentation. It is a very painful stuff until unless when we kind of like work with automated processes on this one. So if it is especially with the API thing, let's have a kind of like a tools which would allow us to automate the documenting stuff like Swagger kind of stuff. So deprecation policies. This is kind of like additional stuff, and within the in-house build solutions, it is kind of like looks optional, but this would allow us to ensure uh, the auditing within our team. Okay, so when this future is having the policies tagged with the depreciation, then we will be kind of like revisiting that part, and we will make sure that auditing is happened in that part. So that is kind of like quite useful. All right, let's go to the next one. So the simple use case, like I've started a kind of like a Mac solution, and especially when someone starting their journey from monolith to kind of like a headless structure. So let's take an example on this picture. So earlier, kind of like we had entire components are built in within the single server. Now we are kind of like dissecting them. We are moving them, or like we are arranging them into kind of a decoupled way, where front end stuff will be handled using Next.js solution, and backend will sits in the kind of like integration. I mean, at the edge of the integration layer. In between, we have a kind of like a API which can be iPaaS or like an enterprise service bus. We'll be discussing that part in the upcoming slide. So the integration layer will be sits here. So what it does is like multiple microservices, and the complexity in managing such a large number of microservices, it's kind of like always inevitable. So we can use kind of like a service mesh, as I explained earlier. So that would makes our life easier. So we don't have to kind of like worry much on resilient part or traffic part or like load part. So it's all kind of like configurations. We just need to make sure it is done so that the system will be autonomous and it will take care by itself. API security. So the important of keeping this security within the API gateways, because user is always, every request from the user is always to be considered kind of like a non-genuine request. That's how we were doing it in the backend as well. They're not directly communicating to the backend, but every request to the front-end system will be rerouted back to the backend system with the same authorization context. So backend, it is a responsibility of backend to check whether the context identity in terms of identity token, whether that request is genuine or not. So we can go with kind of like a OAuth or JWT tokens, and even we can go with kind of like a rate limiting control within the microservices. Next thing is like a data consistency across microservices. Achieving consistency across distributed microservices is always challenging. We can go with the kind of like a event-driven architectures, which we discussed earlier. We can go with the kind of Apache Kafka to ensure the eventual consistency across the real-time synchronization. Performance. As I mentioned before, like from the end user perspective to uh, paint the page or to return the results, hardly nowadays like we will be expecting like it should not be more than 3 to 4 seconds. When we have a large number of systems which is kind of like taking care of our request, we need to ensure it is returning the responses at earliest as possible. So that part we can kind of like always work on the lean approach, especially in the API services side. So if it is kind of like often the same data to be used, we can use it in the CDN side to make sure like the redundant calls is happening. Redundant call is not happening in the backend services side. All right, so I'll go to the next one, the integrations part. Especially in the composable solutions, that integrations can be done through three different ways. So let's start from the right hand side. ETL is a kind of like earlier days. We had seen something to, I mean, it was quite successful, but this is kind of like not real time. Enterprise service bus, it is quite good, but it is kind of like a required efforts to build in the components stuff. iPaaS, it is a kind of like a trend, so we can easily adopt kind of like a platform as a service providers. There are quite a lot they're available in the markets. And like iPaaS always is having kind of like cloud first approach. So here, right, the pre-built connectors, even like we can have Sidecore Connect. So that works on Walker 2 begin the scene, and they'll be having kind of like iPaaS providers. They have pre-built connectors available across like multiple systems. I've seen almost like 400 to 500, especially in Magento and Dynamics. They have quite good kind of like connectors available in the market. So ESB is it's like as I mentioned before, it is a kind of like a middleware. It will ensures the communication between your front end to kind of like your source systems. ETL, it's a data integration part. As I mentioned, like it would uh, transferring the data. It would make sure the system's connected through the data as a batch processing, delta, one-off, those kind of stuff. So the key differences. Uh, if we go with the kind of like iPaaS, right, it is best suitable for cloud-based or real-time integrations between like SaaS components. And if you go with the kind of like a enterprise service bus, ideally it is recommended for large enterprises with a complex and message-driven workflows. And when someone is kind of like not ready to go with the kind of like a SaaS and they wanted to go with interconnected systems within the premises, uh, like I've seen quite large number of use cases on this data service bus like that. ETL, if it is kind of like a records processing and if it is kind of like offline, they wanted to process the data, you can go with the kind of like ETL. And in the next slide, I've just provided the comparison. So in terms of scalability, like iPaaS, it is like being a kind of like a SaaS nature. So it's a highly scalable. And EBS moderately because it requires some efforts and we need to take care of data flows, and that may create a kind of like a performance bottlenecks. And it is, yeah, by the time it was recommended to go with a kind of like high volume batch processing, but that is not suitable for real time scaling. Deployment model, so again it's a kind of like cloud based, and this one kind of like a hybrid. ETL, again, like it is kind of like a hybrid. So just some kind of like differences based on my understanding, I've just drafted it here. Okay, so it's a typical solution. I've taken example with iPaaS. Even we can take an consider this iPaaS as nothing but we have our Sidecore Connect. So we have our front-end headless front-end solution, and we have our XM Cloud. Experience Edge is in mid. Whenever there is a kind of like a data update, Next.js solutions trying to get the data from layered services, and XM Cloud also kind of like pushing the data whenever there is a publishing is happened. But here, the typical solution, like in the e-commerce solution, we wanted to bring the product data or like a e-commerce capabilities. Those stuff, it always kind of like driven through this Next.js solution. But to provide the product listing or product details, let's consider iPaaS is asked to fetch the data from our e-commerce solutions. So it's a kind of like a typical solution. Now let's get into deeper. On left side, we have a front-end solution. And here I have a kind of like a XM Cloud SaaS CMS. My product details, in this side, I'll just explain like whether it is Dynamics or Magento or Info and Sales Marketing Cloud, Salesforce Marketing Cloud. So I had worked mostly Dynamics and Magento Info not directly because we were using Intel in MIT to process this data in the post GREs. But I've just thought of kind of like keeping it in the loop on this area. Now, in the e-commerce solution, I wanted to provide the product listing page to the next day solution. So I wanted to retrieve the product data, but it is kind of like a tailored data. We will be having scattered data within the dynamic system, but once it is tailored, we wanted to capture them as an entity. So let's see like how do we kind of like capture them. From here, we can adopt Kafka system. So whenever there's a product being updated and when the product is tailored, we will be passing it to the producer. And this will kind of like this data will be kind of like available for the subscriber system. We have our own catalog service, which will fetch the data from subscriber and pass it to the storefront queue. It is a Azure bus service. Again, from Azure bus service, we have a storefront sync service. It will fetch the data and it will pass it to the XM Cloud. It will create as an entity item nodes using authoring APIs, which is available in the GraphQL. So this way, if you see here that product information, whether it is kind of like a batch processing or like any ad hoc processing, this will always ensure the data gets created in the XM Cloud system. So either it is one-off or even delta changes, everything will be taken care here. Now let's take an example like I have the data available in the CMS. I wanted to update the data. I need the data to be available for my Next.js solution also. So let's kind of like queue this data back to the indexing. So this way I can index my data in the search tags, and that data will be used for Next.js solution. This is kind of like for the storefront, a product catalog perspective, it is fine. Next, I wanted to kind of like takes care of my e-commerce functionalities, cart and checkout flow. So when the cart operations or checkout operations, when it happens, then that request will be passed back to checkout service containers, and that information will be passed back to checkout authorization queue. Then my purchasing service, which sits in the producer side of Kafka, will retrieve the information from checkout and it will be passed to the Kafka system. From Kafka to e-commerce system, I'm passing it back. Sorry. So this way, I can ensure the systems are decoupled. And the reason for using containerization is to make sure that services are kind of like secured and resilient, also kind of like a scalable. So here, if I wanted to kind of like meet the demand for the growing PLP or like a PDP listing. So just I need to kind of like increase the configurations of this service. I don't need to kind of like touch this part. So this is the beauty of having composable solutions. All right. So next, go to the next slide. Transitioning from monolithic to composable solution. So this is a kind of like a phase or like considered as an inception stage. First, we wanted to kind of like uh, analyze and accept our current monoliths limits. Uh, in the previous picture, like I've seen, like when the growing demands are like when I mean during the peak time, in order to make sure the load is handled, we need to kind of like ramp up the entire resources. That is kind of like another one disadvantage. That is a kind of like limitations within the monolith systems. So that is something. Those are all kind of stuff we're gonna be addressing when we're transitioning from monolith to composable structure. Then clear goals. We need to kind of like define now what is our goal. Like just because of doing some stuff, I don't want it to keep the system. For example, like I wanted to use Sitecore Connect, but my use case here is like very small. I don't want it to often get the data product in inventory anyway as part of the product itself. I'm getting it, then I don't need separate connector for that one. So we need to define set clear goals. Though we have a place to incorporate multiple components or like multiple available features, we just need to define what is required for our goal. Then we need to kind of like always starting from the smaller picture. If it is a kind of like monolith solution, let's try to carve out the product listing functionalities alone, then details page alone. So something like though we have a kind of like bigger picture, we need to start it from the small to ensure the system is kind of like tied up together. Then in the for the rinse and repeat. So I can take an example on this one. So here, right, it is not kind of like in a single flow or like it is in the single go. We had done this one like when as soon as kind of like we had implemented this stuff, we need to make sure how do we handle the ad hoc request, ad hoc product updates. So those kind of requests like in the continuous improvements, we will be taking care of it. Uh, Sorry. Then third thing is like a traceability and observability. Being a kind of like such a large scale system, observability and traceability is always kind of like a complex. And it's a kind of like centralized team, like a SRE team. They'll be monitoring. We need to kind of like set the alerts, and we need to make sure we need to define the business rules and business rules and kind of like a benchmarks on the individual systems to raise any alarms in case of if something goes wrong. Then it is not kind of like an immediate suggestion to kind of like get rid of monolith solution. Probably when you have a monolith solution running with the 50% of load on actual traffic on the PLP, let's go with 50% of traffic with microservices side, micro front-end services side to make sure it is goes side by side well. Then once we have confidence, slowly we can increase the traffic into a composable solution and we can decrease the traffic into monolith system side. Yeah, evolve and optimize. Same like we can continuously measure our progress and we can see like the progress on the composable solution, the traffic rerouting that part. Once we gain the confidence, then we can kind of like optimize it further. Yeah, I think we are approaching in the end. Uh, in the end, like in a summary, what I wanted to bring in is like uh, whatever the kind of like a challenges or like whatever the kind of like a use cases which we had seen, it is kind of like a common and in generic, and we can kind of like go with the use cases. And every time, I'm not sure like we have a Sitecore Connect and we need to prepare the recipes and we need to kind of like make sure the right app is connected at the end. Uh, Still it is evolving, but in the current needs, right, because uh, Sitecore 9 is on the way down, and we are getting kind of like pressures from 4.7.2 and 4.6 to be migrated in the new systems. And don't know like whether we have a time to kind of like take care of all these things. But while we have the system stabilized in that part, we can have our own custom connectors to make sure this part. So I believe like this was happened in the last 2 to 3 years, and the preparation and the implementation which took almost kind of like 1.5 years for us. Then In the configurations area, like where we can see mostly operation and data silos. So though operation silos can be handled within the team by adopting best practices, data silos is always kind of like unavoidable because we are moving ahead with the approaches of fast failing approach. So data silos, let's not kind of like be stubborn with the data. Let's collect the data as much as possible. Then we need to refine them. Then starting points. So first we need to kind of like understand our current monolith solutions. Then we need to dissect them to see what are the components can be decoupled in a kind of like a easier way. And from there we need to carve out our focusing points and we need to start using them. Traceability. And the final one is traceability and observability. We discussed a lot on that part. And composable architecture, right for you. So it depends on the system. If we are our requirement and our growing demands is can be fulfilled with the SaaS features which is built outside, yeah, we can go with that one. But if it is something like we wanted to work on and we wanted to customize it, then we need to double check whether it is really helping the kind of like our growing demands, our growing kind of like requirement parts. So that's a question. That's a kind of like a self review for us to think through. That's all. Then finally, we are in the brainstorm break. Sorry, because at the time, like I was rushing through on this one, but it's a kind of like a QA kind of place where you can shoot out your questions, and that's going to be helpful for me also, kind of like exploring different dimensions.
Guys, any questions, please post in the chat or you can raise your hand and ask Satya. Okay.
All right, not an issue. Like even offline also, you can post the questions, so which
I think
are
it was a
always
great
appreciable.
presentation, Satya. I think really it was a great presentation and a lot of knowledge and also a lot of areas to be like focused on because it's really important that we set clear goals. As I understand also like only one we should not go ahead that if we have a lot of tools or a set of tools that to be used, we should not be like going okay, this is the tool that can be used. We should clearly set the goals and also should be backtracing. That is also one of the great point I understand here. So I think yeah, even I did get a lot of different perspective things. So it was a really cool presentation, and then slides are
Thanks,
really
Yamini.
good.
Thanks, Yamini.
So any questions?
All right.
Okay then. Chalo then. Thank you all. Bye bye. Have a great day.
Thanks, everyone.
Yeah.
Thank you so much.